Now we are starting question number 4 and 5 for the work power energy of M1. Question number 4. The mass of 700 kg is traveling along a straight horizontal road. The resistance to the motion is constant and equals to 600 Newton. Part 1. Find the driving force for the car engine at the instant when the acceleration is 2 meters per second square. Part 2. Given that the car speed at that instant is 15 meters per second, find the rate at which the car engine is working. Since we know that it is moving on the horizontal surface, so driving force minus resistive force is equal to MA. We are going to calculate the driving force, which is equal to resistive force plus MA. Resistive force is equal to 600 plus mass of that particle is 700 into acceleration of that particle is 2. So it should be equal to 600 plus 1400, and that should be equal to 2000 Newton is the driving force for this particle there. Now they are asking, find out the work done by the driving force when its speed is constant there 15 meters per second. We know for this part, work done, power is basically equal to work done by driving force over time. So R, power is basically equal to driving force into velocity. So driving force we have calculated there equal to 20,000 into velocity is given there equal to 15. So this should be equal to 30,000 watts. This thing can be equal to 30 kilowatts because 1000 watt is equal to 1 kilowatt. Now we are going to start the next question, 5 of this. A load of mass 1250 kg is raised by a crane from rest to the on the ground to the rest at a height of 1.4 meter above the ground. The work done against the resistance to the motion is 5750 joules. Part 1. Find the work done by the crane. Part 2. Assuming that the power output of the crane is constant and it is equal to 1.25 kilowatt, find the time taken to raise the load. since the crane is going to upload that, it is at 1.4 meter is the height of that. It is at rest, it is again at rest at this position, and you are going to upload that. The weight of that object is being vertically downward to that position there. And we know that work done by driving force minus work done by resistive force is equal to gain in potential energy of that load there. So work done by driving force is work done by resistive force plus mgh. So this is equal to mg into height plus potential energy of that part there. So work done against the resistance force is basically equal to resistive force into height plus mgh. So resistive force total work done is basically equal to 5750 plus mass of that particle is 1250, d is 10 into height is 1.54. So work done by driving force is basically equal to 25,000 joules for the first part. The second part is there, find the time when the power is 1.25 kilowatt. Since power is equal to 1.25 into 1000, so that should be equal to 1250 watt. So work done by the is equal to power. So time is basically equal to work done by driving force over power, and work done by the driving force is equal to 25,000 divided by the power there is equal to 1250, and that time is equal to 20 seconds. So this is the calculation of that part into the second of this crane, and we have to use